We are now recording. Welcome to the engineering principles class for September the 30th. I looked at the assignments that you guys turned in. I noticed that some of you waited until the very last minute. Some of you just barely turned them in. Not a good idea to leave it to the last minute like that. Everybody has turned something in though, so that's good. That's an improvement. Three of you, the assignments that you turned in were seriously lacking. So I have sent you a private message just now asking you to stick around after your class is over so that we can talk about that. I definitely want to do that. So the three of you who got that message, that private message from me, after everybody else signs off, stick around, we need to talk. Many of the submissions were really outstanding. You did a great job of exactly what I wanted to do. So let's just remind ourselves, because some of you are kind of in between, kind of so. So let's remind ourselves what it was that I was looking for. Okay, I wanted an explanation of the design of experiment process, and a few of you put that in there. You used the words design of experiment and the letters DOE. In fact, tell you what, let me turn on my white screen here, maybe. Okay, so I want you to use this phrase in your write-ups. So remember, what you guys submitted to me today was just a rough draft of what you're going to be submitting in your final report. So the phrase design of experiment, which is also known as D, that's a D, O, E, okay? That is the goal of this activity that we're doing right now, okay? So when you guys write up the final reports, which by the way will be due next time we meet, remember I'm going to want an introduction. And in that introduction, you have to explain why we're doing the project. And every year I always have some students who say, well, the reason we did this project was to learn how to make rockets. Bzzzt. No, that is not the reason we did this project. The rockets are just an excuse for doing the project. The reason we did this project was so I want you guys to have experience using DOE, design of experiment. That is the reason we did the project. We could have done this with rockets. We could have done it with electrical circuits. We could have done it with a whole bunch of different things. The rockets are just the excuse. The goal was for everybody to get experience using the DOE process. And so some of you said that in your write-ups, and so that was great. I was very glad to see that. Those of you who didn't say that in your write-ups, make sure that you say it in the final report, because remember, what you submitted today was just a rough draft for what you're going to submit later. And same thing with the functional specification that you submitted last time we met. That also is just a rough draft. The final report, which is due next time we meet, you need to take the functional specification and the engineering specification and put them together into your final report. So while we're on the topic here, let's go ahead and let's make sure that everybody fully understands what needs to be in the final report. Okay, so final report, which is due next time. Okay. All right, so first thing I want to see is a title page. All right, so that's going to look something like this. So here's the paper, and I want to see some sort of interesting picture. I don't care what it is. A picture of a rocket would be the appropriate thing. But hey, something that is in some way related to the project that we did. Okay, and so then I want to see the title right here. So you could think of it. You could call it the Pneumatic Rocket Project if you want, because that's what I've been calling it up until now, the Pneumatic Rocket Project. Yeah, let's do that. Let's all call it that. And then I want you to, so we're going to have title, and we're going to have some artwork. And then you're going to say by, and then it's going to be your name. And then it's going to say for, and then it's going to say Mr. Hendricks's Engineering Principles class. And then the last thing is I want to see the school name right here. So Academy for Math, Engineering, Science. That goes on the title page, all of that just on one page all by itself and centered nice and neatly, okay? That should be the first piece of paper that I see. And some of you did that on what you submitted today. That was great, okay? And now on the next page here, I want to see an introduction. Okay, and that is the thing that talks about why we did it. Okay, it might contain a few sentences, very, very brief about what we did, but most important, I want to know why we did it. And I don't anticipate that the introduction will be very long. So if this is a piece of paper right here, I want to see introduction. And by the way, I want that to be bold and underlined. Okay, and then I'm thinking just, a couple sentences, maybe one paragraph. That's all we need. Okay, then the next section here is going to be the functional spec. Okay, and because I don't anticipate that the introduction is going to be very long, I want the functional spec to be on the same page. Now, if your introduction were to go really long, okay, then you can maybe put it on another page.
For you guys too?
Yeah.
Yeah.
I couldn't understand your question there. Can you say that again?
I asked if you had lagged out.
Oh, did I? Did I lag out for a while there?
Yeah, just for like a few seconds.
Okay, just a few seconds. Okay, so yeah, you can see on here what I want. So title page, hopefully you got that. So introduction, maybe a half a page at most, maybe only a third of a page. The introduction doesn't need to be very long. And then, so if the introduction is as short as I anticipated it would be, don't put the functional specification on a different page. Just put it right on the same page where the introduction is. And then, so you're going to have your functional specification after that. And so the functional specification will probably bleed over onto the next page. Okay. All right. And so I don't anticipate it's going to take more than that. All right. So the next thing in the final report is going to be the engineering specification. And so if your functional specification ends halfway through the page, then don't go to a new page for your engineering specification. Go ahead and put your engineering spec right here. Okay. And then and remember, these are all going to be bold and underlined. All the section headings are all bold and underlined. All right. So the engineering specification goes there. And now in this case, the engineering specification is going to be a little different than it was last time. I mean, last time I wanted detailed instructions on how you made your airplane. This time, that's not really required. I mean, I do want some instructions, but I don't anticipate that's going to take very much. I'm thinking, 1 or 2 paragraphs will be enough to describe how you made it. The most important part of the engineering specification is I want you to tell me how you came up with your testing matrix. So basically what you sent me today, okay, or at least what most of you sent me today. A few of you didn't have a testing matrix described in there. But I don't just want the testing matrix. I want to see how did we come up with that. I want you to talk about the fact that we looked at all the variables that could possibly affect the flight of the rocket. And we came up with 10 different variables. And we decided that if there were 3 levels for each one of those, like for fin size, if we had no fins, regular fins, and big fins, 3 levels, right? And for nose, we had no weight, and then 2 pennies, and then 4 pennies, so 3 levels. So we did the math, which I want you to describe, and we decided that there was over 50,000 possible combinations of rockets that we would have to make in order to test everything. So we decided, well, that's not reasonable. So then we decided to narrow it down to just the top 3 variables that, using our intuition and our experience, we figured out, okay, these 3 variables are probably going to be the ones that have the biggest effect. And so all the other variables, we're going to set one setting for each one of those, and all of our prototypes are going to be exactly the same as far as those other variables go. The only thing that's going to be different in our prototypes is in these 3, what I call the primary variables. Okay, I want you to talk about that. And then I want you to talk about the fact that even then, we still have 27 prototypes we'd have to make. So even that's too many to really be realistic. So then I want you to talk about the fact, okay, so we decided that instead of having 3 different levels, we're just going to go with 2 levels. We're going to have a low and a high. We're not going to do a medium. And so that brought us down to 8 prototypes, which is a manageable number of prototypes. Okay, I want to see that whole thing. I'm going to walk me through that process, which most of you did. I mean, when I look at what you guys submitted, most of you did a really good job of describing that, but some of you not so much. Okay, so remember, that's what I want to see. And then finally, then I want to see the 8 prototypes. So I want to see prototype number 1 looks like this. Prototype number 2 is going to have this, which again, most of you did that one pretty well. All right, so go back to our whiteboard here. All right, so we've got the engineering specification there. And so then the last one is going to be the testing results. Okay, so that's what you're going to be doing tonight. Tonight, you're going to make all 8 of the prototypes. You can't just make 3. So one time I was thinking that I'd just let you do 3 prototypes, but the more I thought about it, the more I thought, it's not that hard making these rockets. It's not unreasonable for me to ask you to make 8 of them. Okay, so tonight you're going to make 8, or sometime in between now and next time we meet, which is next week. You're going to make your 8 prototypes. You're going to launch your 8 prototypes. When you launch them, try to blow with the same amount of force each time, because otherwise it's not really a fair test. And you're going to measure the distance and you're going to report the results. Okay. And so I would not recommend that you video all 8 of them. Although you can, because you are going to have to submit a video, but I only want to see a video of 1 launch, and I want it to be your best launch. So if I were you, what I would do is I would shoot all 8 of your prototypes and maybe even shoot them multiple times. That would be a really, that would be a great way to earn extra credit on this project, is shoot each of your prototypes maybe 3 times. So you're actually doing 24 launches now, and average them out, because there is going to be some variability, especially given the fact that we're blowing this using our lung power rather than using a compressed air. So that'd be a great way to earn extra credit. And then, once you have decided which of your prototypes you think is the best, then get out the video camera and do a couple launches and send me the video of your best launch, and also tell me how far it went. Right. So that is the assignment for today. Now, does anybody have any question about that? Okay.
I have a question.
Okay, go ahead.
So when I was doing the thing that was due today, I was having a hard time remembering how many rockets we would have built if we did all the variables and all the all the modes,
Okay. You want to talk through that? That'd be good. Here, let me put on my headsets here, because I worry if I don't wear my headset, then it might induce some weird feedback. Okay, so let me turn on the whiteboard. And let me ask you guys to explain the answer to that. Okay, so if we have, let's say that we have 2 variables. Let's just say we just restricted to fin size and the weight in the nose cone. And we decide we want to do 3 levels for each one. So we're going to do a low, a medium, high for each one. Can somebody please unmute yourself and tell us how many rockets would we have to do to to test all possible combinations?
We'd have 9.
You 9 with a question mark in your voice or 9 with an exclamation mark in your voice?
9.
Okay, so we got 2 variables. So the first variable, okay, we got 3 possibilities for that. Okay. And then the second variable, we got 3 possibilities for each one of those. Okay, so it looks like me like we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so however many levels we have raised to the power of how many variables there are. So we got 3 raised to the second power is 9. Now, in our case, we decided that there were a total possibility. We could have done 10 different variables if we wanted to. Okay. And so if we were to do 3 levels, okay, that would be 3 raised to the 10 power. Okay, which was 59,000 and something, if I remember right. So
It was 59,049.
Oh, okay. So 59,049. So if we were to look at 10 different variables, so we've got fin size and weight in the nose and length of the rocket and this and that, 10 different things. If we were to do 3 different levels for each one of those, that we would have to build 59,049 prototypes, which is obviously not possible. Okay, so that's how the math works out there. Does that answer your question there, Ron? Or Juan?
Yes, that's what I was looking for. Thank you, sir.
Okay, good. And by the way, that's what I'm looking for too. When you guys submit the final report, I want more detail. I mean, some of you did a great job. Okay. And now I haven't assigned numbers to your homework yet. I'll do that later this afternoon. Some of you, I'm gonna, instead of giving you 10 points, I'm gonna give you 12 points because I really was impressed with what you did. And so I'll give you a few extra points on that. But in the final report, for sure, I want a detailed explanation of how many prototypes we would have to make if we went with 10 levels and 3 variables. And then how many would we have to make if we went with 3 variables and 3 levels? And then we finally decided that we're going to end up with only 3 variables and 2 levels, and that means 8 prototypes. So that's what I want to see. Okay. Thank you for asking that question, Juan. That was a really important one. Anybody else?
If we already included the matrix thing in our engineering specification, do we have to explain it again?
Well, your final report is going to have a copy of the engineering specification in it. Okay. This is something that I want to make sure everybody understands. What you submitted today is just a rough draft. The final report has to have the engineering specification in it, as well as the functional specification too.
Okay.
Yeah. So if you did a good job in what you submitted today, well, you can just copy and paste that into the final report. And many of you, that's the case, but some of you, I want you to go back and do it better. So I'll tell you what I'm going to do. Later this afternoon, when I have a little more time, I'm going to sit down and I'm going to write comments to what you submitted today. I didn't have time to write the comments when I was looking at them this morning. Some of you just barely submitted them a few minutes ago. So I didn't write any comments on them yet. So later today, I'll go through and I'll say, hey, I like what you did here, but this other thing here, I want you to elaborate a little bit more on that, okay? So look for those comments, and in the final report, I want you to incorporate the improvements that I suggested. Last chance for questions. Any others? Hang on just a sec, I got a cough. All right. So we are going to end the live portion of the class here. Some of your teachers call it the synchronous part of the class. That does not mean the class is over. We still have almost an hour. We've still got 55 minutes left of class time. You need to use this time to work on your rockets, work on your final report. And then over the weekend, actually launch the rockets, do the testing. And so next time we meet, let's see, today's Wednesday. So that means Friday, but Friday is that goofy day that counts as a B day, but even though we don't meet. So it looks like Tuesday of next week is when we're going to meet again. So on Tuesday of next week, I need to have a really well done, professional looking final report with a title page, with all of the sections that we talked about, the introduction, functional specification, engineering specification, and then test results. I want to see all that. Plus, I want a video of your best launch. That's all due for Tuesday of next week. So you've got almost a whole week to work on it. Okay, well, if there are no other questions, then now the three of you who I asked to stick around, please stick around. The rest of you, you can log off. Yeah, remember to type bye. Thank you. Yeah, remember to type bye into the chat box. And then I will see you guys next Tuesday. And I'll go ahead and stop the recording so the three of us can talk without fear of it being recorded.